Today we are going to revise lesson number 12, that is study of sound. So basically, how will we wake up early in the morning? By the sound of clock or alarm clock, or the our parents wake up, the sound of our parents. Next, can we clap with one hand? So there is answer will be no, we can't clap with one hand. So it is there should be two objects. Require two objects to produce any sound or clapping of that sound. So clapping sound, what is that sound, how that sound is produced? Sound is passed from the source to the ears, then how that sound is heard by our ear, and how we identify and how we react that sound. So these are the topics we are going to discuss and see what is sound. So the sound is a form of energy which creates sensation of hearing in our ears. So this energy is in the form of waves, that is sound waves. So next topic, that is how that sound is produced. In case of bell, electric bell or the drum, so this sound is produced due to vibration on that object. So now what happens to the both the object to produce sound? In case of bell, or the next example we have taken here is a vibrating ruler. So sound is produced by vibrating that body. Now in our case, in human being, sound in human is produced by voice box in the larynx. The larynx contains two vocal cords which are stretched across. Between the two vocal cords there is an air gap for passage of air from lungs. When that air passes through this air gap, the two cords vibrate and the sound is produced. Now how do we listen that sound? So we can listen that sound through sound waves. Now there are two types of sound waves. First, that is longitudinal waves, and the second is transverse waves. So we will see in detail what is longitudinal waves, the types of waves in which the particles of the medium oscillate about their central or the mean position in the direction parallel to the propagation of the wave. It is called as a longitudinal wave. Now the next is transverse waves, the type of wave in which the particles of the medium oscillate about their central or the mean position in the direction perpendicular to the propagation of the wave, are called as a transverse wave. The best example is the wave created by dropping a stone in a still water. The particles of the water oscillate up and down. Now, how that sound is created? The sound is created by creating a disturbance on any vibrating substances. Now on that vibrating substance, that vibrations are created, and those vibrations are carried forward with the help of two successive compression rarefaction. Now how it will happen, we will see in detail. The propagation of sound requires a medium. Without medium, sound cannot travel. So medium is necessary for propagation of any sound waves. Now these sound waves give rise to a chain of compression and rarefaction. Compression means a place of higher density, and the rarefaction means a place of lower density in that medium. Now, at any moment during the propagation of sound wave, we would find alternate bands of compression and rarefaction of medium, that is a band of greater or the lesser density. Now, figure A, figure B, these are the two figures. First figure, that is figure A, shows the changes in density, and figure B shows changes in a pressure. Now, the figure C shows both pressure and pressure or the density in a graphical form. So we can see that, we will see in detail that graphical picture. We have seen how sound is produced. Sound is produced due to vibration of any object. How sound is propagated? Sound is propagated in the form of compression and rarefaction. Now, there are two types of waves. First, we have seen that the longitudinal waves, the type of waves in which the particles of the medium oscillate about their central or the mean position in direction parallel to the propagation of the wave. Parallel is important. And in case of transverse waves, the types of waves in which particles of the medium oscillate about their central or the mean position in direction perpendicular to the propagation of the wave. The perpendicular is the important word in case of transverse waves, and parallel is important word in case of longitudinal wave. Now, there are some terms which are used in sound. First is wavelength of sound, time period, amplitude, frequency of sound wave, and the last, that is pitch and loudness. These are the terms we are going to discuss. First, the wavelength of sound waves, which is indicated by Greek letter lambda. The time taken for one oscillation of pressure or the density at a point in a medium is called as a time period, and it is indicated by capital T. The amplitude, which is maximum value of the pressure or the density, is indicated by capital A. Frequency of sound waves is indicated by nu, the letter nu. The value of frequency determines the pitch, that is high or the low, of the sound, while the value of amplitude will determine the strength or the loudness of that sound. Now, the distance covered by a point on the wave in unit time is called as a velocity of sound wave. Velocity is equal to distance upon time. So at any point on sound wave covers a distance equal to lambda, that is wavelength, in time t, that is time period. Therefore, velocity is equal to wavelength upon time period. Symbolically, it is presented by v is equal to lambda upon capital T. Now, the velocity of sound is equal to wavelength into frequency. How that formula come? The velocity is equal to distance upon time. That formula is given. At any point on sound wave covers distance equal to lambda. So distance is equal to lambda, that is wavelength, and velocity is equal to wavelength upon time period, that is v is equal to lambda upon t. The 1 upon t is equal to nu. Therefore, formula becomes v is equal to nu into lambda. Nu is called as a frequency, and the lambda, that is wavelength. Therefore, formula becomes like velocity of sound is equal to frequency into wavelength. Now, in any medium at fixed physical conditions, the velocity of sound of different frequencies is nearly the same. The velocity is highest in solid and least in gaseous state. It increases with increase in temperature of the medium. Now, There are some factors which decide or determine the velocity of sound in gaseous medium. The first is temperature, second is density, and third is molecular weight. How these factors are determine the velocity? The velocity of sound is directly proportional to the square root of the temperature of the medium. This means that the increasing temperature 4 times doubles the velocity, which is directly proportional to the square root of capital T. Now, second is density. The velocity of sound is inversely proportional to the square root of the density. This means that the increasing the density 4 times reduces the velocity of velocity to the half its value. So velocity is inversely proportional to the square root of density. Next, that is molecular weight. So the velocity of sound is inversely proportional to the square root of molecular weight of the gas. So this means that increasing molecular weight 4 times reduces the velocity to the half its value. So V is inversely proportional to the square root of capital M, that is molecular weight. Now we will shortly see the relation between temperature and with the velocity of sound. The velocity of sound is directly proportional to the square root of the temperature of the medium. So next, uh, what is the relation of density with the velocity of sound? The velocity of sound is inversely proportional to the square root of density. Next, the velocity of sound is inversely proportional to the square root of molecular weight of that gas. Now, there are three types of sound. First, infrasound, the frequency having lower than 20 hertz. Second, audible sound, that is frequency between 20 hertz to 20,000 hertz. And the third type is ultrasound, that is frequency greater than 20 kilohertz, that is 20,000 hertz. Above 20,000 hertz or the 20 kilohertz, the frequency the called as a ultrasound. Now, the sound with a frequency smaller than 20 hertz is called as an infrasound, and it is observed the sound produced by pendulum, sound greater than generated by vibrations of the earth crust just before earthquake. It is also infrasound. The dog, mouse, bat, dolphin, these are the animals have spatial ability to hear that infrasound. Who can hear waves with frequency up to 25 kilohertz? The children's which are under 5 years of age. There are some creatures, insects also can hear the frequency up to the 25 kilohertz. Now next is ultrasonic sound or the ultrasound. The sound waves with frequency greater than 20 kilohertz are called as ultrasound or the ultrasonic sound. There are examples: bat can produce ultrasound, mice can produce ultrasonic sound, dolphins are also producing ultrasonic sound. Next, which are the types of sound? That is audible sound, infrasound, and ultrasound. What is the frequency of audible sound? The audible sound has a frequency between 20 hertz to 20,000 hertz. Next, that is what is the frequency of infrasound? The frequency lower than 20 hertz is called as a infrasound. And what is the frequency of ultrasonic sound? The frequency greater than 20 kilohertz or the 20,000 hertz is called as a ultrasonic sound or the ultrasound. Now next topic is that is reflection of sound. That is the famous experiment. The light waves, sound waves, these are reflected from a solid or the liquid surface, and these sound waves are also following the laws of reflection. The smooth or the rough surface is needed for the reflection of any sound. Now, how will you determine whether the reflection, the surface is good or bad reflector for particular sound? So, how much of the incident sound is getting reflected will decide whether that reflector is good or the bad reflector. A hard and a flat surface is a good reflector. Now there are some examples: the cloths, papers, curtains, carpets, furniture. These can absorb sound instead of reflecting it, and therefore these are called as a bad reflectors. Now sound follows which rules? Sound follows laws of reflection of light. How do we classify good or the bad reflectors? A hard and the flat surface is the good reflector, and the surface which absorbs sound instead of reflecting sound are called as a bad reflectors. Now there are some phenomenons which are based on sound. First we have seen that echo, and the second is reverberation. Now we see in detail what is echo. So echo is if we shout loudly at echo point, you will hear a same sound just after a while, and this sound is called as an echo. An echo is a repetition of the original sound because of reflection by some surface. Now, which are the conditions? First, in order to able to hear a original sound at 22 degrees Celsius, that is we considered as a room temperature, what must be the minimum distance between the source and the reflecting surface? At 20, the velocity of sound in air is 344 meter per second. Our brain retains a sound for 0.1 second. To hear a distinct sound, a sound should take more than 0.1 second after starting from the source to get reflected and come back to us. So now we will calculate that distance, minimum distance between the source and the reflecting surface to get distinct echo. The formula is distance is equal to speed into time. So speed is 344 meter per second. That is the speed of air, speed of sound in air, and the time to recognize that sound is 0.1 second. So calculating that distance will be 34.4 meter. That will be the total distance. To hear distinct echo, the reflecting surface should be the minimum distance of the half of the above, that is total distance, that will be the 17.2 meter. Now next concept or the next natural phenomena, that is reverberation. The concept of reverberation: the sound waves get reflected from the wall and roof of the room multiple times. This causes a single sound to be heard, not once, but it is continuously heard, and this continuous hearing is called as a reverberation. How this happen, we will see. The time between two successive reflection of a particular sound wave reaching us becomes smaller, and the reflected sound get mixed up and produce a continuous sound of increased loudness, and the original sound we can't hear clearly, or which cannot be depicted, deciphered clearly. So that is called as a reverberation. Now there are two concepts which are based on this sound. First, that is sonography, and the second, that is sonar. We will see in detail what is sonar. The full form of sonar is sound navigation and ranging. Now this sonar has two parts. First, that is transmitter, and the second one, that is receiver. Now we will see how this sonar is working. The transmitter produces and transmit ultrasonic sound waves. These ultrasonic sound waves travel through water, strike underwater object, and get reflected by them. The reflected sound waves are received by next part, that is receiver on the ship. That receiver will convert that ultrasonic sound into electrical signals, and these signals are properly interpreted. That interpretation between transmission and reception, the time difference will be noted, and this time difference, this time and the velocity of sound in water will give the distance from the ship of the object which reflect the waves. So sonar is used to determine the depth of the sea. Sonar is also used for searching underwater hills, valleys, submarines, icebergs, sunken ships. Now, what is reverberation? Shortly, the sound waves get reflected from the walls and the roofs of the room multiple times, and this cause a single sound to be heard not once but continuously, and this is called as a reverberation. Next, what is the full form of sonar? Full form of sonar is sound navigation and ranging. Which are the two main parts of the sonar to work? First is a transmitter and second is a receiver. Now moving on to the next, sonography. It is the technique which is also based on ultrasonic sound waves. Sonography technology uses ultrasonic sound waves to generate images of internal organs of human body. This is useful in finding out causes of swelling, infection, pain, etc. Now, the condition of heart, the state of heart after a heart attack, as well as the growth of fetus in pregnant woman inside the womb. Pregnant women are studying using this technique. Now, this technique makes use of probe and gel. This is the probe. The gel is used to make proper contact between the skin and the probe so that the full capacity of the ultrasonic sound can be used. The gel is applied on the skin outside and the internal organs are studied with the help of this probe. Probe will transmit the rays, ultrasonic waves, high frequency ultrasonic sound is transmitted inside the body with the help of this probe, and the sound reflected from that internal organ is again collected by that probe also, and fed to the computer, and computer will generate an image of internal organs. So you can see the image which is obtained by ultrasonic sound. So as this method is very painless, there is no pain, it is increasingly used in medical practice for correct diagnosis. Now, shortly we will go through the questions. Which technology is used to make images of internal organs of human body? The ultrasonic sound waves are used to generate images of internal organs of human body. Name of technology is sonography. What is the function of the probe in sonography? The high frequency ultrasonic sound, that is ultrasound, is transmitted inside the body with the help of probe, and the sound reflected from the internal organ is again collected by the probe and fed to the computer, which generate the image of internal organ. Now, next is our human ear. You all know about human ear. The ear is an important organ of our body. We hear sound because of our ear. When sound waves fall on the eardrum, it vibrates, and that vibration is collected. These vibrations are converted into electrical signals and which travel to the brain through the nerves. The ear can be divided into three parts. First, that is outer ear. Second, middle ear. And the third one, that is inner ear. Now we will see in detail. Outer ear, or we can call pinna. It is its particular funnel-like shape helps to sound and pass that sound into the middle ear. Now, the function of this outer ear or the pinna is to collect the sound waves and to pass that sounds through the tube to the cavity in the middle ear. Now, next is middle ear. Middle ear is there is a thin membrane in the cavity of the middle ear called as an eardrum. The function of that eardrum is to vibrate. When the compression in the sound wave reaches that eardrum, the pressure outside increases and get pushed inward. That eardrum is getting pushed inward. There will be low density or the low pressure. It will push outward, relax position, and that pushing inward and outward will give the electrical signal. The pressure outside decreases and the membrane get pulled outward. Sound waves causes the vibration of that membrane or the eardrum. Now this vibration will converted to electrical signal. Next, inner ear has a structure resembling to the shell of snail that is called as a cochlea. The cochlea receives that vibrations coming from the membrane and it converts into electrical signals. These electrical signals are passed on to the brain with the help of nerve. That nerve is called as an auditory nerve. The nerve of ear is called as an auditory nerve. This auditory nerve is connected between inner ear to the brain. Now, this auditory nerve will give electrical impulse to the brain, and in the brain there are association neurons. Those association neuron will collect the information which is previously collected in that brain, and this association neuron will decide which sound is this, and then it will be reacted with the help of. Now this association neuron will decide, make a signal, and it will give proper orders. Now in this case the brain will analyze that signal, if that information is new, it will be not giving any signal. It will be new for brain. But if that voice is previously heard, it will be recognized that voice is from this person. Now we have seen a dash is the repetition of original sound because of reflection by some surface. Okay, so can anybody answer? Students? Sir, can we open up the for some questions?
Yes, sir. Yes.
Students?
Yes, sir. Echo is the repetition of the original sound because of reflection by the some surface.
Excellent. That echo is the repetition of original sound because of reflection by some surface. So next, to hear a distinct echo, the reflecting surface should be at minimum distance of dash meter. What will be the minimum distance to hear a distinct echo?
17.2 meter.
17.2 meter. Excellent. Now, the next question. The sound wave get reflected from the walls and the roof of the room multiple times. And this causes a single sound to be heard not once, but continuously. And this term is called as a dash.
Reverberation.
Okay, good answer. That is the reverberation. In reverberation, that continuous sound is produced, and the original sound, we can't hear that original sound. Next, dash is the short form of sound navigation and ranging.
Sonar.
Sonar. Yes, sonar. All letters are capital SONAR. Sonar is the right answer. Sonar is the short form for sound navigation and ranging. Now, dash and dash, these are the two main parts of sonar to work.
Transmitter and receiver.
Yes, transmitter and receiver. Transmitter, what is the function of transmitter?
Transmitter produces and
Ultrasonic
transmits
sound.
ultrasound waves.
Okay. Transmitter produces and transmit. The name itself is showing transmitter produces and transmit ultrasound. And the receiver, what is the function of receiver?
The reflected waves are received by the receiver.
Okay. Reflected waves or reflected sound is collected or received by the receiver, and that receiver will be connected to the computer, and that computer will give a proper image of that object. Which object is this? Okay, with the help of sonar, what is the use of that sonar?
Sonar is used to determine the depth of the sea
Depth
and
of the
also
sea,
used to search.
Determine the direction, distance, and speed of an underwater object.
underwater object, distance, speed. Okay.
Yes.
Okay. Now next, the technology which is used to make images of internal organs of the human body. Obviously, that is
Sonography.
sonography. Okay. Which are the main parts? Which are the main parts to do that sonography? There are two main parts which are used for doing sonography.
The first is probe.
First is probe.
Let me check. Gel.
And second one, gel.
Gel.
Okay. What is the function of gel?
Gel is used to make proper contact between skin and the probe.
Very nice. Gel is used for making proper contact between probe and the skin.
Skin.
Okay. So what is the function of probe?
High frequency ultrasound is transmitted inside the body with the help of probe.
Okay.
And the
High
sound
frequency
reflected
ultrasonic sound are passed or transmitted through that probe. And again, these are received by probe.
Gel.
Probe. Receiver and transmitter both are in, right? Both receiver and transmitter are present in that probe. Next, function of probe. We have seen just now. Now, human ear is divided into major part. First is outer ear, middle ear, and inner ear. What is the function of outer ear?
Outer ear collect the sound waves and pass them through a tube to a cavity in the middle ear.
Okay, the main function is to collect that sound.
Sound
Function of
waves.
sound waves. Okay, what is the function of middle ear? What is the function of middle ear? Yes, students.
the pressure outside it increases and
Is
it get pushed
pressure outside
inwards.
increases and it gets pushed inward.
The function of middle ear is only that middle ear has a part that is function of eardrum, right? Functioning of eardrum occurs in middle ear, right? Now you are telling the functioning of eardrum. What is the function of eardrum?
Compression in a sound wave reaches
Compression in a sound wave will push that eardrum inside, and rarefaction will pull out. It will release the pressure. Compression will create the pressure, and rarefaction will release the pressure. In that way, the vibration will be created in eardrum, right? So what is the function of eardrum? Vibration, creation of vibration. Creation of vibration. Yes, students.
and get pushed inwards.
Okay. That is creation of vibrations. Now, what is the function? Which part is important part in inner ear?
Cochlea.
What is that called?
Cochlea.
Cochlea.
Yeah.
Okay. What is the function of cochlea?
The cochlea receives the vibration coming from the membrane and converts them into electrical signals which are sent to the brain, to the nerve.
Okay. The cochlea is doing the conversion of this vibration into electrical signals. Okay. That is the main function of cochlea. So now these electrical signals are carried through which nerve? What is the nerve which carries that electrical impulses or electrical signals from cochlea to the brain?
Auditory nerve.
Auditory nerve. Auditory nerve which carries that impulse or the electrical signals which are created by converted by cochlea to the brain. Okay. Okay, student. Thank you. Okay, sir.
Yes, sir. Thank you so much, sir. Hello.
हाँ, sir. Okay.
Yes, sir. Yes, sir. Thank you, sir.